Hey there. Welcome back. I fixed my squeaky chair and we're here for the end of section 2. So we have been thinking about linear functions the last few sections. We're on the last subsection of there and we're dealing with modeling piecewise linear functions. So that's our one learning objective, is to be able to model these kind of functions. And so piecewise and linear are both phrases we've heard before. Piecewise-defined functions we saw in section 1, just sort of in a general sense, and linear functions we've been talking about in section 2, of course. And so piecewise-linear sort of merges those two things when you have a piecewise-defined function where the individual little pieces themselves are lines. Okay, so thought I would tackle this from a word problem perspective, since I know how much word problems are just your favorite thing ever. So we'd have a nice concrete example of doing this from a word problem perspective, and then if it's not a word problem and you're putting a function like this together, then it ought to be easier than this because we won't have to do all that translation. Okay, so we have some limited production shoes. When they're offered free, then all 500 pairs that are produced are demanded. And you can put purchased in quotation marks here because, of course, free means that you paid $0 for it. But when the price goes up to $800 a pair, then demand goes down, and it's going down at a constant rate to 450 pairs. And then once it passes $800 a pair, then it's again decreasing at a constant rate, and it does that until it reaches zero, demand reaches zero, when we hit $2,000 per pair. So these got to be some nice shoes. Okay, and then the last sentence is our actual goal here. So write a piecewise defined function for the daily demand for the shoes as a function of unit price. Okay, so, right, the usual feeling you should have now, this is what, 6.5 lines of text to read through. Typically, for these kind of word problems where we're doing this translation, you will probably read through all of this and then just feel like none of that stuck in your head at all. That's totally fine, but what we might try to do is first identify what the goal is and then go back and reread it with that goal in mind. So the problem is the goal is usually the very last sentence. So we don't see it until we reach that part. So if we notice that our goal is to write a piecewise defined function, so there, and this is for daily demand as a function of blah, blah, blah. So we'll do that usual strategy where we look at this phrase and see daily demand for shoes, and then here's this little connector thing as a function of, and then unit price. So remember, this is a great helpful little tidbit to pull out. Every time we see this phrase, blank as a function of blank, we're talking about the output in the beginning and the input as the last quantity being measured here. So in other words, we're being told that our goal looks something like get, find, well, we get to make up a variable for demand. It's daily demand, so man, seems like D would be a good bet, is a function of, and then unit price. I guess here we're being forced into a particular variable, so sorry about that. We can't pick X this time, or T, but we're told that that input variable is going to be P for price, I'm assuming, and so there's our goal kind of mathified. Again, if we didn't have other information, we wouldn't be able to get very far with this, but now that we know our goal is to find a formula, maybe if we dig back through this original statement, then we can find what we're looking for. Okay, so with that in mind, now we know we're supposed to find a formula for this demand as a function of price, so let's read again. So when they're offered free, all 500 pairs are produced. So maybe this is where I want to start kind of cataloging stuff. So I guess first up, so stuff we know, one is that when price is 0, because that's what free would mean, then demand is 500. So once we hit that, we've got 1 point that works for us. Now let's keep going. So maybe it's worth underlining that, I guess. So when offered free, then all 500 pairs are produced. Okay, so there's one. Okay, price goes up to $800. Daily demand drops at a constant rate. So I guess there's maybe two things here. We looks like if we have a particular price, then now we know another value that pairs with that. So we have $800 and 450 pairs. So this is P equals 800 and then that takes demand to 450. I guess it makes sense, right? If it gets more expensive, then probably fewer people are willing to buy it. So dropping from 500 to 450 maybe makes sense as that price increases. And one other piece of helpful information there is that it's dropping at a constant rate. So constant rate is our catchphrase for a linear function. So whatever's going on between these 2 points, it's linear. It's going to be some kind of line that it drops off. Because if you have 2 points, there could be all kinds of crazy squiggly things that connect those. But with that extra phrase at a constant rate, then we know it's a line that connects those 2 pieces. Okay, what else do we have? I'm going to run out of colors before we're done, I'm pretty sure. Okay, for prices at or above. Okay, so if P is greater than 800, daily demand again decreases at a constant rate. Okay, so decreases at a constant rate. So this is again linear. But the thing is, this segment and the segment that we're talking about right now, they may not have that same constant rate. They seem to be sort of separating these in the word problem setup here. And then that demand keeps dropping until it hits 0 when the shoes are priced at $2,000 per pair. So let's see if we can get one more color. Maybe we'll go back to black for this. So the last bit says when the shoes priced at 2,000 and then demand reaches 0. So P equals $2,000 gets paired with, so it finally gets so expensive that nobody wants to buy it, is what it looks like. And then we've run out of information and we're back to the original goal, which is to write a piecewise-defined function for this. So there's nothing at this point that requires that we get a picture of sorts, but I think it would still be valuable, honestly. So if we are trying to figure out what it is that's going on with this, I think a visual might be pretty helpful. So again, I'm not so much convinced that we need the negatives on this. Oh, it's going to bother me that that's not super straight. Okay, let's try this again. Maybe that's better. Okay, so let's think about our elements here. So our axes are going to be price. There's our horizontal axis. And then demand is the thing that we're measuring on this vertical axis. And I guess one thing we know basically is a starting point. So let's go back to green here for a second and just see if we can kind of get all these things mapped on here. So when P is 0, demand is up at 500. And that's actually, I guess, the biggest number that I see anywhere in here. So maybe along the vertical axis, we can kind of make some tick marks that take us along, and let's do it from this direction. So let's go 100, 200, 300, 400, 500 kind of thing. And then we know at price 0, then we have ourselves a point right along that vertical axis, that D axis. We know another point. We know when we get over to P equals 800, then demand has dropped somewhat. So let's get ourselves a horizontal axis here. I'm going to try to pick these in a slightly devious way. I'm going to pick them in increments of 400. So here's 800, here's 1600, here's 2000, so 2400 all the way over here. And then, so what we know is this gold point, if you will, the one that corresponds to 800 and 450 would be directly above 800, and I guess kind of halfway between the 500 and the 400 mark there. So maybe somewhere like so. Okay. And then the connection between those two things, we're being told it's a constant. So we can use this to connect those 2 points with what we should be reasonably convinced is actually a legit line. So if we, I'm going to move my point around. Don't move my green point. And let's see. Oh, don't you do it. Okay, I'm going to freehand. So the connection between these two things ought to be perfectly straight line, just like that. One more try. All right, it's as good as I'm going to get. So that's a nice connection. We've got a piece of this picture. Again, we're still building toward a formula, so it's going to be a minute, but I think we're on our way. For prices greater than 800, so whenever we're farther to the right along this horizontal axis, the function's linear again, so it's some kind of straight line. We're just not really sure where at the moment. But here we go. The very last point is 2000 is our p-value, and then it drops down to 0 for demand. So it's a horizontal axis intercept, basically. It's a p-axis intercept because we've dropped the vertical value all the way to 0. And then once again, we're supposed to get a linear function between these. And if I can actually manage this, then you might notice that it does in fact appear that these two slopes are different. There's not a single line that connects all three of these points. So demand drops off kind of slowly here, and then it drops off more rapidly for the last part. I'm sure you could come up with an explanation for why that might be the case, but that's where we are. Okay, so building an actual function. I guess what I know so far, one other thing we know basically is that the thing we come up with is piecewise. So it's going to look like, remember those little curly brackets, some kind of formulas, and then if our input takes some values, and then some different stuff if our input takes some other set of values. Okay, so let's start using this stuff. So we know, so let's find some formulas. And from the description, it looks like we're going to have two distinct pieces, one line here and one line there. Okay, so Formula 1. Not to be confused with NASCAR. So we will take this first set of stuff. So I'm going to use D, and then kind of like our previous example, I'm going to use little subscripts for these constants, A1 and B1, just because I know we're going to have a second formula for this other component, and I don't want them to get kind of mixed up, I guess. Okay, so with that, let's keep that information available. So this is actually great. So on that first segment, this green point is the y-intercept, which is perfect. That means that B1, that first B value, is exactly this value, which is very helpful. And then I guess our slope is something we'll still have to figure out, but we're resourceful people. We can make this work. So our slope is going to look like A1, and we got to take a couple of points. And that's where the visual kind of helps me out, is I remember now that like the gold and the green points are both on this line. So we can go, say 450 minus 500 for the difference in the outputs. And then we're dividing by difference in the inputs. So I started with the gold one, so we're going 800 minus 0. And that's not a great number, but I don't want to be too judgy about this. So then now we're looking at a weird slope, but a slope nevertheless. And it turns out that's actually exactly what we need. We've got enough information to make this happen. So our first formula looks like, what is that? Negative 0.0625 times t. And then plus, what was it? We were at 500 to begin with. That was our b value. Oh, if you're already yelling at your device, I'm breaking my own rules. It's not t that's our input, it's price, p. How could I forget price? It's me. Okay, Formula 2. So that's this second component, which also appears linear, which is fantastic. So we're looking at our second constant times price, or a second slope constant times price, plus some, a different y-intercept. Here's where we got to be really careful. So we're going to do slope the same way. So A2 is going to get calculated the same way we just worked on Formula 1, because that's how slope works, 2 points. So we've got this point down in the bottom right here. We've got this point at kind of the junction between these two little linear pieces. And those seem like great points to use for our slope. So this has an output of 0. So there's d equals 0, and then subtracting the numerator there. Okay, perfect. And then 2000 minus what was that, to the price of 800 that we had before. And that is another fraction. Sorry, not sorry, but it is always nice when they come out to be whole numbers, but I'm sure we'll survive somehow. So this is great. We're sort of 3/4 of the way there. We have one slope and one y-intercept, another slope, and then another y-intercept. And here's where things usually go squidgy. So the temptation is that since we used this point to start with, that we just think, oh, then b2, this b value over here, must be 450 because that was our starting point. But that's actually not how the math treats this. If you imagine, so here's our blue line. It's actually, if we had sort of a dotted line that continued up and to the left here, it would actually hit the d-axis somewhere back here. It's just that our piecewise-defined function never lets it. It doesn't let it because this line only gets to take charge once we hit a price of 800. So we have to do the old standard thing to figure out this b value. We have a point to work with, any point. We plug that in and into our formula, and we see what b value falls out of that. So that's what we're going to go to now. So now we got to find b2. So we're going to use our formula d and just plug in everything we know, including one sample point. I guess that doesn't really matter. This one has a 0 in it, which usually makes things nicer. So if we have demand of 0, what was our slope? There it is, negative 0.375. The price that goes with this demand of 0 was $2,000. And then there's B2. So then B2, I guess, is whatever 0.375 times 2,000 is, which I believe ends up being 750, I want to say. Okay, so here's us putting it all together. So we found formula 1, we found formula 2, and now we're going to put all the pieces. So the eventual thing we were supposed to figure out was a formula for demand, some function of price. Okay, so our first formula we figured out a couple minutes ago. So here's our negative 0.0625 price plus 500. And that's true if our price is between 0 and where did it stop? It stopped at, so price 0, I mean, I guess negative prices don't really make any sense. And then it stopped at 800. It wasn't totally clear, and it doesn't matter in this case, whether the second line was in charge right at 800. Like we'd have a little open circle for one of these things, for whichever one is less than or greater than. And in the wording, the point is used in both spots. So for prices at or above, so we might say, since for prices at or above would include 800 in this second piece of the line, we may just give the or equal to component to that second piece. So that would mean this is only for right up until, but not actually at 800. And then the second one, the formula we just figured out now, so this was negative 0.375p plus 750. And that one is in charge if p is less than or equal to 800 and less than or equal to, we'll see if I can actually get the eraser to erase things for me. So just to give a little more space so this isn't crowded here, up until 2000, where that price crashes down into the horizontal axis and demand is 0. Okay, so I'll draw my little arrow over there just a little less prominently. Okay, man, if anything deserves a victory box, it's that. Oh, it's gold. Oh my goodness. Okay, we'll find a way to cope with the gold victory box. Maybe that's just the ultra. Okay. So these are pretty involved. Try not to do these to you all the time because they definitely take some time, especially these word problems, to kind of piece all tease out all the English and turn it into math. And then, of course, there's at least 2 different lines that you're finding equations for. So that's twice as much work as finding a regular line. So I will respect your time with these and try to not to make you do them very much in time-constrained environments. Okay, that is it for section 2, linear functions. We'll be back with section 3 and start looking at some quadratics, and polynomials, all kinds of great stuff. Talk to you then.